I am going to explain about the objectives of this study. First is to examine how the corrosion process is impacted by elements such as moisture, oxygen, pH, and electrolyte concentration. Next is to assess basic corrosion and rusting control techniques, including painting, coating, or using inhibitors. Third is to examine how different environmental conditions influence the rate and severity of corrosion and rusting. And lastly is to evaluate the negative effects of corrosion and rusting on the strength, appearance, and usability of iron materials.
What is corrosion? Corrosion refers to the deteriorations of material due to chemical, electrochemical, or other reactions. When iron is exposed to air and certain chemical over a long period, it reacts to create hydrate iron oxide, which is commonly referred to as a rust. It can occur on different surfaces, for example, skin, woods, and metal. Next, what is rusting? Rusting is a type of corrosion that involves a chemical process leading to material failure and safety hazard that create the formations of red or orange on a metal surface. Rusting mainly happens when a metal is exposed with air and water. Rust or corrosion can only impact iron and its alloy. Understanding corrosion and rusting is essential for creating efficient prevention strategies such as protective, coating, alloying, and corrosion inhibitor, which help extend the lifespan of metal structure and reduce maintenance costs.
This slide explains several methods used to prevent rust. One method is protective coating, which include oiling, greasing, painting, and metal plating. These coatings slow down rusting by blocking oxygen from reaching the iron. Can also be coated with a less reactive metal such as tin. Tin acts as the cathode due to its high electric potential, and it helps protect the iron underneath by preventing oxygen exposure. Another method is by allowing iron to be in contact with a more reactive metal. This active metal donates electrons to the iron. Galvanizing provides both a protective surface layer and cationic protection. It is self-protecting because it reacts with oxygen and carbon dioxide in the air. The hydroxycarbonate forms seals any openings and prevents further contact with oxygen and the iron or zinc. The final method involves aqueous solutions that are in contact with iron, such as those used in automobile radiators. The solutions contain chromate salts and organic compounds like tributylamine. They form a protective, impermeable layer. Tributylamine, which is derived from ammonia, reacts with organic acids from antifreeze decompositions, reducing acid catalyzed corrosion while also acting as a surface coating. This slide explains how different conditions affect the corrosion of iron. Harsh environments such as water and acidic conditions can speed up the corrosion process. Corrosion is an electrochemical reaction where the substances involved exchange electrons with each other. Oxygen plays an important role by removing electrons from the metal. This causes the metal to partially dissolve or, in some cases, form a protective layer. In certain environments, this process happens faster than in others. A high salt concentration in water increases the rate of chemical reaction, which accelerates corrosion. In coastal areas, the air contains more salt compared to inland regions. As a result, metals near the coast corrode faster even without direct contact with seawater. Acids such as sulfuric acid increase corrosive effects. Similarly, highly alkaline substances like sodium hydroxide can also speed up corrosion, especially at extreme pH levels. Next, this slide explains how corrosion and rusting occur. Rust is essentially a hydrated form of iron trioxide. The rusting process requires both oxygen and water, and it usually happens faster in acidic conditions. Water is essential for the reaction to proceed smoothly. When different metals are present, they form separate areas on the surface. The more active metal loses electrons while the other metal gains electrons. Oxygen is reduced at the secondary metal. When these metals come into the contact, electrochemical cells are formed, causing the metal to corrode and decay. Rusting can be reduced by applying a protective coating such as oil, pigment, or paint, and the coating must be properly finished. However, if the coating or plating is damaged, corrosion can increase. Iron also corrodes more rapidly when it is in contact with tin. At the anode, iron loses electrons to form iron-2 ions. At the cathode, oxygen reacts with hydrogen ions and electrons to produce water. The overall reaction shows iron reacting with oxygen and hydrogen ions to form iron-2 ions and water.
Okay, for this part, there are many factors why the corrosion and rusting happens. First, as we know, moisture, which is water, act as an electrolyte, allowing chemical reaction to occur on the metal surface. Second is acid and pollution, especially when raining. We know that the water inside the rain has acid gas like SO2, which is sulfur dioxide, and carbon dioxide, CO2. It can speed up the corrosion. Next is salt. Salt can be electrolyte. For example, when the building beside the sea, salt water increase electrical conductivity, accelerating corrosion. So, as we know lah, sea environment. Next is temperature. Higher temperature increase reaction rate, causing faster corrosion. And nature of metal, purity, composition, and position in the electrochemical series affect corrosion resistance too. And lastly, surface condition. Rough or damaged surface corrode faster than smooth or coated one. So when the corrosion and rust happen, of course it can give us disadvantages, especially for our properties. First, it can weaken metal strength. Corrosion reduces mechanical strength, making structural unsafe. Next, structural failure. Rusting can cause collapse of buildings, bridge, and vehicle, and increase maintenance costs. It will require a frequent painting, coating, or replacement. So, for example, fence was rusted, you need to paint it back. And lastly, contaminations. Rust can contaminate water, chemical, or food stored in iron container. So if the container was rust, we need to avoid to store it for food or drink.
In conclusion, the corrosion and rusting behavior of iron under various environmental conditions was successfully investigated. The experimental results showed that the corrosion is an electrochemical process that requires the presence of moisture and oxygen, and that the rate of corrosion increases significantly in the presence of electrolytes such as salts and acids. Iron placed in saltwater and acidic solutions or environment rusted more quickly than iron placed in air or clean water. This is because salt and acids help the chemical reactions that cause rust to happen faster. Rust, which is called hydrated iron trioxide, was clearly seen on the iron samples and was related to the environment they were placed in. The study also showed that the rusting can be reduced by using protective methods such as paints, coatings, or corrosion inhibitors. Overall, this study helped us to understand why rusting happens and why it is important to prevent corrosion in everyday life and engineering applications.